Hey, what's up everybody? It's Mike from Cornfield Customs, and we are back in the shop today, and I have some welding to do on this section of the underhood panel on the 1960 Cadillac. So stick around as I show you my process and some of the other misconceptions I have seen floating around on how I weld all my sheet metal seams. So stick around. All right, so what I've got here is a section of the underhood panel on the 60 Cadillac. And I have a seam right down the middle here that you can see. I've got it all tacked. Everything's hammered and dollied back up to flush. So from here, I need to weld it solid. I do my welding process a little different than some people do, and a lot of it comes down to your welding process. So I like to TIG weld everything. All my sheet metal gets TIG welded, chassis get TIG welded, everything. So the process of TIG welding sheet metal, in my eyes, is a totally different process than MIG welding. So we're not even going to really talk about MIG welding just because I don't use that here. I think TIG welding is a far superior process to MIG welding sheet metal. I'm sure there's going to be varying opinions on that, but that's my own belief system, and it works better for what I tend to do. So with that being said, when I TIG weld my sheet metal, I get it all tacked, hammered out just like this one is, and then I will start at one end and I will weld a continuous bead from one end of the panel all the way to the other, or as few starts and stops as humanly possible, because sometimes if you're doing, say, a quarter panel, it's not really possible to not have a start and stop. But we want to minimize that. And in some of my other videos, we've talked a little bit about why I do that, so I'll just recap here. With welding in one continuous weld across a panel, you get even heating and even cooling across that entire weld seam. So you get, everything gets hot and expands, and everything cools and contracts at the same rate across the panel. If you do a bunch of little stitches, you're going to get a hot zone and a cool zone in that little area. We'll just say it's 2 inches across. So you're going to get 2 inches of hot, cold, then you're going to come back and you're going to do 2 inches and 2 inches, and you're going to get hot, cold, hot, cold, hot, cold, hot, cold, hot, cold. And you can see that in your heat affected zone, that you get dips around your weld seam. It's not a consistent weld, and it's not a consistent heat affected zone. So that is going to get you inconsistencies in your warpage. And while we're on the topic of warpage, I've seen a lot of misinformation going around about welding, and lower amperage does not mean no warping. One continuous weld seam across a panel does not mean no warping. So anytime heat is introduced into your metal, whether it be from welding, from using a shrinking disc, using a torch, a grinder, anything that can add heat into your panel, there's a little bit of science going on, and no matter what, you're going to get a little bit of distortion or correction depending on what you're doing, but your metal is always going to move, and this is why. So when heat is introduced into a metal, it gets the molecules all excited and they start moving around. That's not really what causes the warping. The warping is caused by, as those molecules start to cool down, they've moved around just a little bit and they start to contract. So they found a new home to go into and they're contracting. The cooling or contracting of a weld or heated area is what causes all of your warping, because it is drawing in that heat affected zone, pulling the material inward towards its center of heat to be contracted. So that's causing all of the warping all the way around on your panel. So when you hear somebody say, if you welded at 15 amps, you're not going to get any warping, that's false, because you are still introducing heat into your panel, which is going to cause expansion and contraction. And again, when you contract something that's been heated, the molecules have moved around and they contract a little bit farther than where they started, and that gives you a warp. So that all kind of ties together with what I'm saying about even heating is even cooling. You're going to get even expansion, even contraction, and a nice smooth warp, which is going to be way easier to correct later on. With that being said, always keep that in mind, that when you're welding, anytime heat is going to be introduced, you're going to get a warp no matter what. So we're going to focus on keeping it even, keeping it consistent, and then we will correct the warp after the fact, because that's all we can do when welding a panel. So I'm ready to weld this up. I've got our TIG welder all set up. I'm going to go over some of the details, and then we will get to welding this panel solid. I will do the weld. I'll probably speed it up a little bit just so you're not sitting there watching me do a normal weld, but it'll be continuous with no breaks in it, so you can see that I don't stop. And then we will talk about the heat affected zone. You can see the consistency, and you'll be able to see the warp. Hopefully it's minimal, but we won't really know until we get in there. And with talking about that, I kind of forgot to mention it, so I'm going to bring it up now. The consistency in your fit up is also going to help dictate a nice, even weld and a nice, even draw or warp. So if you have a nice tight gap and that gap opens up, you're going to have to spend more time, more heat, and more filler rod, which will contract slightly different than your parent material, which will increase your warpage in that area. So fit up is very critical, as well as even heat and even filler material as you go across the weld seam. So let's get the machine set up, we'll talk about it, and we'll get this thing welded. All right, our welder is all set up. We are set at electrode negative for welding steel and stainless. We are set at 60 amps, which I've mentioned in other videos. A good rule of thumb is 1 amp for every 1/1000th of material. So I'm running 16 gauge, which is 060. That's about where I'm at. So we're going to start there and see how things go. And we will go over to our flow meter and we will check and see where we are. So we are about 15 on our flow. Then here at our torch, I'm running a number 8 cup and a 1/16 inch tungsten, nice and sharp, with about 3/16 to a 1/4 inch of stick out on our tungsten. And now we can get ready to weld, and I will be using 030 filler rod, which is laying here on the table. And one other thing before I get to welding this up, I mentioned we will be using 030 filler rod, and you want to use just enough filler rod to make the weld slightly proud of the parent material. You don't want to add a ton of filler rod, because then you're either going to have to grind that, or if you try to hammer the weld back into itself, it's not going to be able to quite do that, and it's going to push everything out, and it'll make a bulge in your panel. And you also want to make sure to add enough filler rod to where you're not getting undercut. So some people out there think that you can fuse weld sheet metal panels, which you can, but you're going to have a slight undercut, because it's going to pull that material in your weld puddle from the parent material, leaving it slightly low. With your filler rod, you just want to use just enough filler to make the weld seam slightly proud of the parent material, and then when we hammer it out, either with a hammer and dolly, or in this instance, I will use the power hammer just to make it quick and easy. You just want it to be slightly proud of the parent material, so when you hammer the weld back into itself, stretching out the heat affected zone, it'll go back to flat, and you can run a DA over it, and you are all finished without a ton of grinding. So let's get to welding. Now that the panel is all welded solid and everything's cooled down to the touch, I'm going to move the camera in and kind of do a pan across the top, and you can see the little bit of warping that happened, and there's just a little bit here and a little bit here, but it's very minimal. And you can see across that our heat affected zone is very consistent. I think it'll be tough to see, but our weld bead is very consistent height-wise and width-wise. So when welding sheet metal, I don't give a crap if the weld looks like rows of nickels. I'm looking for consistent heat, consistent filler, and just making sure that everything is going to be good for smoothing this out later. Because what's it matter if it looks like a row of nickels or kind of what I've got here where it's not a row of nickels but everything is consistent? Because once it's hammered out and you run a DA across it, it doesn't matter. You know, this isn't a weld for show and to show off your skill of laying rows of nickels. It is about showing your sheet metal skill and being consistent with the heat and filler to get a nice even weld across your sheet metal, which will make it easier to correct any warping. So let me bring the camera in and I'll show you guys what I'm talking about. So you can see that our heat affected zone is nice and consistent all the way throughout. You know, it's an even width and we're right about an inch wide because I was running the 60 amps all the way through. I started a little lower just so I didn't burn through when we started at our edge here. Then after I got in about a half an inch, I just matted it to the floor and ran wide open all the way across until I got about within a half inch of our edge, and I backed it off a little bit again to keep from blowing through. So you can see that everything's nice and consistent, and I'm going to see if I can use our light here to show the warping. I don't know if you guys can really see the light change as it goes through the warp, but there's a little bit of a low spot here and a little bit of a low spot there. But overall, looking down our panel, you can see just how little distortion there really is. So this will be super easy to correct either with hammer and dolly or on the power hammer. And all we're going to do is we're going to focus solely on the weld and the heat affected zone, because that was the only thing that changed. We don't need to come stretch over here because the only thing that changed was where our weld seam is. And right here you can see that low spot. I caught it in the light just right. But what I was talking about, we're not going to be focusing over here or over here. The only thing that changed was our heat affected zone and the contraction in that heat affected zone. So from here, I'm going to run over to the power hammer and we're going to planish this out real quick and get everything corrected and back to flat. So I'm here at the power hammer, and what I've got is a 36-inch radius lower tool and a flat upper tool. The reason I'm doing or stretching back on the power hammer is just due to the efficiency aspect. You can do this with a hammer and dolly, a slapper, any hand tool that you've got for stretching you can use. But for me, it's all about being efficient and using my time wisely. So I'm going to use the power hammer and we're just going to hammer the weld back into itself, stretching everything out from the contraction of our welding. So let me get this bad boy turned on and we'll get it hammered right back out. All right, so after a quick trip through the power hammer, everything is hammered back out nice and smooth. There's a little bit of warping just at the front, but I'm not gonna get super carried away with getting it much further than it is now until I come back and weld up all of our cleco holes. Because if I spend a bunch of time getting this thing to like 95% and ready to be finished out and then come back and weld up our cleco holes, I'll be taking a handful of steps backwards. So I've got it right now. I'd say we're probably in the 75 to 80% finished realm. And then, like I said, I'll come back and we'll weld up all of our cleco holes and then I can finish the panel out completely. But at this point, I feel that it's a good panel to go ahead and put in the car and I can continue moving forward on more pieces. So that's gonna wrap this video up. I wanna thank you guys for checking it out. Hopefully this is a little insightful into different ways to weld sheet metal than what most of you have probably been taught in your life, because most people I've talked to they cannot fathom the idea of doing a long continuous weld throughout the panel. They've always been taught to tack everything, grind your tacks, hammer and dolly it, come back and tack in between the tacks, or do series of little stitches jumping all over the panel. And just from my experience in the last 18 years of metal shaping, I have found that that causes a lot more warping than just doing one continuous weld. And that means a lot more time spent trying to correct those warps, which is going to cost the client more money, and it's going to drive you up the wall. Chasing highs and lows in panels is my least favorite thing about metal shaping. So if I can eliminate that and get my panels nice and flat with doing continuous welds, I will continue to do just that process. So again, hopefully this was insightful for you guys. I really appreciate you watching this video as well as many of my others, and I hope you continue to watch. So if you guys have liked what you've been seeing with the improvements in the videos on this channel, drop down in the comment section, let me know what you think, whether you like it or if you hate it. You know, any feedback you guys can give me will help me improve on this channel, whether it be from the content I'm covering or some of the editing aspects. So drop down in the comment section, let me know what you guys think, and I will continue to pump out the content. Hopefully it's what you guys want to see and you continue to watch. If you haven't subscribed yet, please become a subscriber, drop a comment, share on your social medias, tell a friend. Anything you can do to help me grow this channel is greatly appreciated. I'm working on a Patreon if you guys want to support what I'm doing on this channel. Hopefully that'll be up and running here soon, so I'll let you guys know on that. And again, thank you so much for checking out this video as well as the rest of my channel. And get out in the garage and make something, not excuses, and we will catch you guys on the next one.